Okay, good day, guys. Today let's look at another example under performance specification in frequency domain. Looking at the question given to us, though it is not written in words form, they just gave you in form of graph. But from your graph, you should know what your peak resonance is, what um your resonance frequency is, yeah. And then from that, you can start solving. At least from the graph only given to us, we know these two parameters I just made mention of now. Now, they say we should find MP, which is our what? Peak what? Okay, our maximum overshoot or peak overshoot, whatever we choose to call it. And we know in percentage. So whatever we is the formula for our MP, we're going to multiply by what? 100. So this is equal to exponential raised to power minus pi zeta over the root of 1 minus zeta square. Now all this multiply by what? 100. Okay, so this is what our formula is. So the reason for this 100 is because this percentage. So whenever we are going to be getting as an answer, we're going to multiply by 100 to get it in percentage form. The only issue is now that we don't know what our zeta is. That's for let's just try for B part, which is what? Peak time. We denote peak time as T with a P. Now this is equal to pi over W brackets, or still anyhow you choose to put it, then square root of 1 minus zeta square. 1 minus what? Zeta square. The same thing here. We don't know our zeta, we don't know what our Wn is. So these two parameters, we need to get them before we can solve for any of these two parameters. Now from the graph only, we are given that our WR is what? 3, and our MR is what? 1.4. MR is what? Peak resonance, while WR is resonance frequency, right? So resonance frequency is 3, peak resonance is 1.4. So we're going to be working with this to get what? Zeta and WL. Now our peak resonance, which is MR, is equal to 1 over 2 zeta multiplied by root 1 minus zeta what? Square. Right? Now we know what our MR is, so we just simply have to substitute into this place to get our what? Our zeta. Okay? Now before we do that, before we substitute, let us first try to make some formula. Let's cross multiply. We have this is 2 zeta root 1 minus zeta square multiplied by our MR is equal to what? 1. Okay. Now this also means that 2 zeta root 1 minus root this is going to be giving us 1 over what? MR. That's dividing both sides by what? MR. Now, for us to get rid of the square root, we're going to be squaring both sides. And when we do that, we have 4 zeta square multiplied by 1 minus zeta square is equal to 1 over MR square, right? MR square. Now, this is from here now we can now start solving. No, not yet. Okay. Let's also say zeta square 1 minus zeta square is equal to 1 over 4 MR square, right? Now we need to find a way to get to kind of solve for this guy. Let us say let's our zeta square be what? A. Now we have that a 1 minus a is equal to what? 1 over 4 r square. Now opening bracket, we have a minus a square is equal to that, right? Right? Now I'm going to be taking this over the other side. We're going to be having a. Okay, instead, let's bring this over here. Bringing this over here, we'll be having that a square minus a plus 1 over 4 r square is equal to what? 0. Is equal to 0. So now we have gotten a quadratic what? Equation. So now from this point we have a square. Let us substitute for the value of what? Mr. So we can make this to become a number. So this will be a minus a plus 1 over 4 times 1.4 square is equal to what? 0. Remember, our a is zeta square is equal to a. Now, solving this, you will have that. Use calculator to solve this. You will click on mode or calculator, then 5 to select for equations, then for 3 for quadratic equation. For the first one representing our a will be the coefficient of this 1. This for the second one, which is our b, will be minus 1, presenting the coefficient of our a here. And for the last one, we will have 1 over, put in brackets, 4 times 1.4 square. Right? It should be giving you 0. When after clicking all those stuff, this is how you write it down. You come in form of like this. Remember to put brackets here. This is necessary. This is how you impute it to the calculator. If you didn't put this bracket, it will interpret it as something else. So after that, you click equal to. That's what our answer is going to be. To give you answer in fraction, you press SD to give it to you in decimal. So we are having that our a is either 0.85 approximately or 0.15. Right? Now we also say that our zeta square is what? A. So substituting that there, we have that zeta square is equal to 0.85 or 0.15. Now finding the square root of both sides, we have that our zeta is equal to, we have 0.92 or 0.339. So square rooting these two answers, this is what I got. Square rooting, understand? So this is what I got. Our system is now having more than one damping factor. So, and they are all under damp. Okay. So with this now, we are going to be finding we have gotten two zeta. We're going to be using it now to also get for our what? Wn. So now we have gotten that our what? Zeta is 0.92 or 0.39. Now, with this value in mind, we're going to be getting our what? Wn. Now we know that our Wi R or omega R, which is our resonance frequency, is equal to Wn brackets the root of 1 minus 2 zeta square, brackets close. Right? Okay, now our aim is to get what's Wn, so we can just say Wn is going to be Wr or omega R, we just call it 1 minus 2 zeta square. Okay, now for zeta equal to 0.92, we have that our natural frequency to be our Wr, which is the resonance frequency, is what? 3 over root 1 minus 2 times the zeta, which is what? 0.92 square. Now this is going to give us minus, is this correct? 3.6. Okay, oh, this is what I got. So for our lambda, our zeta equal to 0.39. Let us see what our Wn will give us. We have 3 over root 1 minus 2, 0.39 square. Now this should give us our answer. We got our answer to be what? 3.5. Okay, that's a 3.596. 596. Okay, so now you can see that truly we have gotten two answers, but you see this one is having what? A negative answer, and our omega n or natural frequency cannot be a negative answer. So what it means is that everything that has to do with this, we won't be using it. That is, we won't be making use of the 0.9, we'll be making use of this. Because of what? It has a negative answer. So we couldn't take one from these two because the two of them are positive. If the two of them was if one of them was negative, we have taken only the positive one. So we only work with positive values. So be conscious of that. Let your zeta always be positive and your Wn be positive. Now, what it means, we're not going to be making use of 0.9, but only what? 0.39. Now, our corresponding value of Wn gave us what? 3.596. So we won't be making use of this anymore. So our zeta is what? 0.39. So we have gotten our zeta and our what? Natural frequency. Now let us solve. We have gotten the two main things, the two babas. Now let us solve. Now for our peak overshoots, we have that MP is equal to exponential pi. Our zeta this time around is what? 0.39 over the root of 1 minus 0.39 square. Right? Okay. All multiplied by what? 100. Please, what is multiplying 100 is the whole expression, including the exponential gain again is multiplying. It's not multiplying the power, but the whole expression. So to be in the safer side, it's better you just solve for this, get your answer, and then multiply it by 100. Now doing that, we have what is exponential in this calculator also. Okay, shift and natural log, that's n. You get it? Then you start solving. So I got it to be 0.26, let's say 264 times our 100, and we have this to be what? 12. So this is 26.4%. So that is the value of our what? MP in percentage. Now for our peak time, using this formula, we have our pi, which you know the value to be 3 points, whatever, but you can still impute pi in your calculator. Your calculator already has a distance for that. When you click on shift and times 10 raised to power x, you are supposed to have your distance. Okay, now for your WN, we have 3.596. Now multiplied by the square root of 1 minus our zeta 0.39, all what? Square. So imputing your answer in calculator. So we have our answer to be what? 0.95 seconds. So that's the answer for this question. This, as you can see, it is quite easy. So that's all for this video. Like, subscribe, share, comment. We'll be taking one more example. So I would advise that you watch the last video under this performance specification in frequency domain. See you guys in the next video and keep being the best version of yourself. Goodbye.